Hey guys, if you missed class today, then this video will help catch you up on what we went over. First things first, this do now is a review from the last class. I want you to look at this GIF and tell me which way that a volcano forms is this way. So I'll just read it. It says the GIF below shows the formation of a volcano through what process? Um, we talked about 3 different ways volcanoes form last class, and so this is which one? And then can you give me a real world volcano example that have formed this way? If you want to go back to last class and check them out, you can. Specifically, check out slide number 20. Yeah. All right. So after our Science of the Day and Learning Target, I got some vocabulary for you. We got some Pear Deck practice in breakout rooms. Students went over how did the Grand Canyon form. I'll have you guys do that too. And then there's a bunch of just practice questions about surface processes. Today we're talking about the surface processes. Our Science of the Day is Steve Poole. He is a graduate from Tyee High School in SeaTac, which is kind of awesome. He went to UW and got a degree in communications. He been working for Como News in Seattle. He went back to UW and became a meteorologist. He studied meteorology. There's a there's a well-known weather professor at UW. His name is Cliff Mass. I actually always use his blog when there's like, is there going to be a storm, a snowstorm or something? I was looking at Cliff Mass's blog yesterday. So if you want to learn more about the weather or know about forecasts, try that. But he was one of the first, Steve Poole was one of the first black TV meteorologists. That means like a weatherman. He retired a couple years ago now. He spent 42 years in broadcasting, so the man deserves a break, I think. But he's a big deal. He was like a household name for the Seattle area. Everyone knew who Steve Poole was. I knew about him growing up. I would see him on TV. This is before maybe you would get your weather news from the internet. You would get it from the TV, and so you had to trust the weather guys. And so Steve Poole was just a trustworthy figure on TV. And I actually did not even know he went to Tyee until recently. So that's pretty cool. Today we're going to be talking about a different kind of geoscience process. Last class we looked at mountains and volcanoes from tectonic plates. Today we're looking at surface processes. And we're going to learn about how they can create and change landforms, because we're all about how these geoscience processes have changed the Earth's surface and continue to change it into the future, because these processes aren't done. We are living on an Earth that is always changing. It's just hard for us to see because some of these changes take thousands of years and we're only around for, I don't know, 60, 80, 100. So I showed you this slide last class. We're talking about natural processes that change the rocky surface of the Earth. Some of these things, like we talked about last class, like mountain building, forming volcanoes and islands, take millions or billions of years. Today we're going to be focusing on the different processes that don't take quite so long. We're going to learn about deposition, weathering, erosion, and they take maybe hundreds, maybe thousands, maybe millions. There's a range to do the different things that they do. And just so we also are talking about a slightly different category would be things like earthquakes, knocking down buildings or knocking down rocks, rocks. Let's go with that. Volcanic eruptions can change the Earth's surface, of course. Meteor impacts can change the Earth's surface. Mudslides, like you see here, can change the Earth's surface. These just happen really rapidly. They don't take millions of years to do their job of changing the surface. We're focusing on this today. So our first word today is a glacier. A glacier is right here. Is one example. This is a slow-moving river of ice. It's formed because when it snows, and then more snow, and then more snow, it compacts the snow down more into ice. But these things are moving. They're moving at rates of like a couple of feet a year, and they move down mountains. They also exist a lot around the North Pole and the South Pole. And they carve out mountain areas. They make a big U-shaped valley. And many of today's low areas, lakes, seas, sounds, were carved by ancient glaciers. I like this GIF here. You can kind of see it's slowly moving, but it drags sediment, it drags rocks, boulders, and tiny little pieces as well with it. Again, it's only moving a few feet a year, but it's slowly grinding these things. This thing is heavy. These things might be, 100 feet tall. So it's extremely big and heavy. And even though it's moving slow, it's grinding down this mountain, cutting into it, digging it out over thousands of years. Our second word today is deposition. This is when layers of sediment that are carried by wind, water, or ice, glaciers, there's the ice part, are transported and laid down. So sediment can be, so the deposition part is actually when it gets laid down. You can, sediment, things that could be deposited are pebbles, sand, mud, salts from water, etc. If you look at this GIF here, it can help you answer this question, which is where do the sediments go that a river erodes away as it rushes downhill? If you look at this, it's supposed to be a river, and the river is bringing down little pieces of sediment, little pieces of sand, little pieces of mud. It's like getting washed up, right, when this moving water, and it ends up making something called a delta because it ends up looking like a triangle, and it forms these deltas at the bottom of every major river. If you go on Google Earth and you type in Mississippi River Delta and stuff, you can see these huge plains of sediment that have been deposited over thousands or millions of years, and they're just getting bigger and bigger. So this is an example of deposition. Weathering and erosion are similar processes. They often work in tandem, not always. Weathering is when rocks get broken down or dissolved. Different things can do this. Heat can break down rocks. Water bouncing up like waves crashing against something over years and years and years and years and years and years. Or wind pushing into something over a long time can break things down. Obviously, living things can do it. Other natural forces like freezing water. Water expands when it freezes, so water going into a crack in a rock and then freezing expands and can break a rock that way. There's a lot of different things that can break rocks down over time. Erosion is when those little pieces of sediment that have been broken apart get moved away, picked up and moved to another place. This could happen from glaciers like ice. This could happen by the same thing, water and wind and just gravity just falling down. All those things count as erosion. And we can look here. I like this. This is like weathering causes the rocks to break down. Erosion transports them downhill. You can see how things like arches, either in the water or on land, can be formed naturally through these processes of weathering and erosion. So, what processes do you think formed these? You can't see the options, but I hope that you're seeing that these can be formed through weathering and erosion. So the weathering would be, in this case, it would be wind blowing around has slowly made this crazy looking shape. The wind, this is just some softer rock in here than up here. And so the wind over thousands of years has broken apart this rock and eroded it away, weathered and erosion. Something similar happened here, but over here it's the water in from waves, ocean waves coming up over and over again for thousands of years are slowly breaking apart this rock into little pieces and carrying those pieces away and shaping this rock into this awesome looking shape. Imagine though, what would happen if you come back in a million years? Will they still look like this, or will they be a different shape? What about in this process? There's two GIFs. These are sand dunes. What process do you see happening here? I hope you see erosion, the movement of sediments, and I hope you see deposition, that they're getting deposited, they're getting placed in a new position. You actually probably don't see weathering because they're already broken down into little pieces. These are pieces of sand. This is probably in a desert or maybe on a beach. Both of those places, sand dunes exist. And finally, the last one here, this map is showing, it's another GIF. Here's the Puget Sound. By the way, we live probably right there. Let's see, does it change? Yeah, it changes. We live like here on this map, or maybe like over here. Anyway, The Puget Sound was carved by glaciers during the last ice age. The Puget Sound is this low area that's now filled with water for the most part. And again, we live like, yeah, it's hard to tell because the zooms in and out. But glaciers, these are glaciers receding as the earth warms up over thousands of years. And those glaciers are grinding up this area. And now that area is full of water, and we call it the Puget Sound. For this slide, I wanted to do an example. So I'll do that with you. I'll have you guys watch the video. The video is all about this place called Kivalina in Alaska. And it is this little community that looks like this. And it's way out on this island that's only connected by the mainland by this like artificial road. And it's usually covered in ice. That's what this video was going to show you. It's usually the outside is covered in ice, which is good because then their island is protected. But because of, I'm just gonna, here we go. Kivalina is in trouble because climate change is causing the sea ice that protects it to melt, and snows turn to rains. The rain and the ocean waves are eroding away the land that Kivalina sits on. Experts think it might be completely eroded away in a few years. I think I spelled eroded wrong. I think there's only one R. Bad. So I looked at this and I tried to use the word erosion, and I used the word eroding and eroded. So I didn't say the word erosion, but I just want you to see that this is the kind of thing I want you guys to be able to do. I wanted to give this is what, 3 sentences? 3 sentences. You guys can do that. So this is my example, and again, this whole video is about it. These are Native Alaskan peoples. It's a social justice issue for sure, because as climate change is affecting the Arctic, the far north, more than it's affecting the poles, the equator or us in between. And so these people are going to be some of the first climate refugees, is what it's talking about, meaning they have to leave their home and move somewhere else, everything that they've ever known for generations, because of climate change. So this is one reason. For breakout rooms, there's a couple of videos here and a little GIF. And I want you to use the words weathering and erosion to explain how any canyon, but specifically the Grand Canyon, gets formed by weathering and erosion. Stop. Here we go. Okay, so then during independent work, you have an optional video, and then you have some examples of surface processes that I want you to write similar answers to, like I did for the Kivalina slide. So if you want to watch this video, it's optional. But if you want a little more practice with how are weather and erosion, there's a cute video, and I feel like they do a pretty good job of explaining it. So go for it and watch the video if you want. The Grand Canyon is awesome. If you've ever been there, or if you ever get a chance to go there, please go. On average, it's 4,000 feet deep. It's huge. That's like Stevens Pass to here, where we are in SeaTac. That is really deep. I think the deepest place is 6,000, but on average it's about 4,000. But if you come back in a million years, will it be deeper or will it be less deep? Why? Tell me that here. Use the words weathering, erosion, deposition. Number 2, this is a place in Mexico. Locally it would be called Arco de Cabo. You in English might be calling it the Arch of Cabo San Lucas. In 1,000 years, if you come back, how will it look different? Tell me. Think about how it was formed. Use the words erosion and weathering, and tell me how it might look different in 1,000,000 years if you came back. I went the wrong way. Number 3, taking it more local. Here is SeaTac, and here's Angle Lake. Can you see your house? Maybe. It's possible that a glacier, I think this is what geologists believe, that a glacier was responsible for Angle Lake. Can you describe how that would work? How would a glacier be responsible for Angle Lake and SeaTac? Use the words erosion and weathering. Number 4, what about coastlines? A lot of coasts have sandy beaches. Why? Why are beaches sandy? Tell me about erosion, weathering, and deposition. Think about oceans and what's in them and how the waves work, and tell me about how do beaches become sandy. And here's the last one. We talked a little bit about the Cascade Mountains. That's where we live. We live way out here. There's my pointer. But in this big country of ours, there's 2 other major mountain ranges and a bunch of smaller ones. There's the Rocky Mountains, which goes from Canada into Mexico. It's huge. And the Appalachian Mountains. And if you look down here, I put some data about them. I'm making you write with data. In the Rocky Mountains, the highest peak is over 14,000 feet. It's actually just a little bit taller than Mount Rainier. And those mountains are about 80 million years old. And the Appalachian Mountains over here on the East Coast the highest mountain is less than half. Just generally, these are much lower mountains. And they're not nearly as like peaked, and the shapes are not like these jagged peaks. They're kind of rounded rolling peaks, and they are almost 500 million years old. So they're 400 million years older than the Rocky Mountains. So I want to know, how are those things related? The height and their age. The Appalachian Mountains are older than the Rocky Mountains. How does that explain why they're also lower? Think about the words erosion and weathering, and think about how old they are and how long they've been doing those, how long they've been eroding and weathering. And tell me why our Appalachian Mountains are older than the Rocky Mountains, which means what has been happening during that time, which can explain why they are so much lower than the Rocky Mountains. That is it. Thank you for spending this time watching the video, and I'll